Hello, this is checkpoint 3.4 from section 3.1. A rock is dropped from a height of 64 feet. Its height above the ground at time t seconds later is given by s of t is equal to negative 16 t squared plus 64. And t goes from 0 to 2. Find the instantaneous velocity 1 second after it's dropped, using the equation f of x, or f prime of a, is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. Okay, so the instantaneous velocity, we'll call it v of t, is actually the derivative of s, and we see that the derivative is written there. This describes the rock falling, and so how fast is it falling 1 second later after it was dropped is essentially what we're looking for. Okay, so let's put in those pieces of information that we need. We're gonna find s prime of t. Actually, we want it specifically at 1. S prime of 1, and that's going to equal to, according to the formula, limit as x approaches 1 of s of t, which is going to be minus 16 t squared plus 64 minus s of 1, and so this would be negative 16 times 1 squared plus 64. And then we want to divide this whole thing by t minus a, so it's t minus 1. And I suppose this is a t variable, so let's change this x into a t. Okay. All right, now we will do some algebra. We'll take the limit as t approaches 1. The numerator, we'll keep this one the same, negative 16 t squared plus 64. And here, let's simplify this. We have 64 minus 16, so this will be 5, 4, the 8, and t minus 1. And this would be limit as t approaches 1. This is a t approaches 1. And we have a negative 16 t squared minus 64 minus 48. I think that's going to end up to be 16. But the 64 is positive, so we'll make that positive 16. Oops, t minus 1. Okay, now we can factor out a negative 16. So we'll have the limit as t approaches 1 of negative 16. And then after we factor that out in the numerator, we're going to get t squared minus 1 over t minus 1. And let's do this here in the same line. Limit as t approaches 1 of negative 16. Actually, we could have taken negative 16 out, but we'll keep it here. And then we have t minus 1, t plus 1, divided by t minus 1. So we'll get the t minus 1s to cancel. And then we will have the limit as t approaches 1 of negative 16 times t plus 1. So we'll put t 1 in for t. We're going to get negative 16, 1 plus 1. So this is going to be negative 32. This is a velocity, so we can use the units feet per second. And so this rock is falling at 32 feet per second. 1 second later after the drop. All right, that's it. I hope that helps.